Welcome to the study 7. Today we will do 6.4 transformations of exponential and logarithmic functions. So either we have a exponential function or logarithmic function. This transformation will be same. Let's start it. The first one is a horizontal translation, so in which the graph will shift left or right. If you have an exponential function, so a function is basically going to change as a fx is original function. We know that fx is original, f of x plus a, or it can be f of x minus a. Here I am considering a is greater than 0 number. That's why I write f of x plus a and f of x minus a. In exponential, it will look like e power x plus a, and in logarithmic, it will look like log of x plus a. Okay. Vertical translation. In the vertical, it will be up or down. So function fx outside changes plus a or minus a. So e power x plus a log of x plus a. It's like this. Reflection about x over y or x-axis or over y-axis. So see, if it is about x-axis, so your fx will change as in negative is completely multiplied. So negative time e power x, negative time log of x. If it is a reflection over the y-axis, then only x will change its sign. X will change its sign. It is e power negative x and log of negative x. This is for this part. Next is horizontal stretch or shrink. It is multiplied inside with the x. Horizontal is something with x. You can see. In horizontal translation, addition and subtraction with x. In horizontal stretch and shrink, a is multiplied with x. So e power ax and log of ax. For the exponential, I am choosing e power. It can be anything. 2 power, 3 power x, 5 power x, half power x, anything. But I am taking just a simple example. Okay. Next is vertical stretch and shrink. Vertical is always outside. So it's outside multiplier. Outside multiplier. Similarly, outside multiplier with the log. Okay, let's start it. Next one, we have to describe the transformation by this and graph it. See, what is this difference? 1 by x power x, 1 by 2 power x, 1 by 2 power x. And there is a minus 4 outside. Outside is a vertical. It is a subtracted, so translate. So what is that? 4 units down. So you can also write vertical. Vertical translation 4 units down. So if I see the graph of 1 by 2 power x. This is the graph of 1 over 2 power x. Half power x, you can say. This. But if I say half power x minus 4, so it will be shifted 4 units down. Like this. It will shift 4 units down. Okay. Alright. Next, we have to describe the transformation e power x plus 3 and plus 2. What is the difference? Plus 2 is there, plus 3 is there, and 2 is here outside. Okay. So if something is added in x, it's a horizontal. It's added in the function outside, it's a vertical. So I will say horizontal translation 3 units left. Vertical and, I've written and, vertical translation 2 units up. And how the graph will look like. See. 1, 2, 3. 1, 2. In this, I'm drawing the graph of e power x. I draw the graph of e power x. It's something like this. E power x. I have to shift 3 units right. 1, 2, 3. And 2 units up. 1, 2. I shifted 3 units left and 2 units up. So here the graph will place approximately. Okay? Next, we have to describe the transformation. See, I will do this. 3 power x is changed to 3 power 3x minus 5. Something is multiplied with this x. Or you can say x is changed to x minus 5. Then x is multiplied by some. I will write 5 units right. Horizontal. Horizontal shift. Horizontal translation 5 units right. And it's a horizontal shrink or vertical shrink? Horizontal shrink because it's a multiple by x. Horizontal. Horizontal shrink. By factor. By what factor? By factor 1 by 3. We have to take reciprocal in the case of horizontal. See this? Here it's a 5 units right. It's shifted 5 units right and then it's a horizontal shrink by factor 1 by 3. This is the translated graph and this is original graph. You can see the difference. Question number B, you can try yourself. Next, we have to describe the transformation. We did the questions of exponential transformation. Here, we are doing the transformation in logarithmic. To see what is the change. X changed to the negative half x. Negative half is not a transformation. It's a 2 transformation applied. X changed to negative x. So it's a reflection across the y-axis. Reflection across y-axis. And half is multiplied inside that. It's a horizontal shrink or stretch? Stretch. If it is a number less than 1, it is a stretch. Horizontal stretch. By factor 1 over half. In the horizontal, I told you we have to take reciprocal. So 1 over half. That's 2. Horizontal stretch by factor 2. The graph will look like, see this? It's a reflection across the y-axis. So it will be shifted this side first. Then it is a 2 units stretched. It's a stretch to 2 units. So it's a stretch 2. Okay. Next we have graph. Let G be the reflection in the x-axis followed by translation 4 units right of the graph and this write the rule. Okay. I will write one by one. I start with 2 power x. First is reflection in x-axis. Reflection in x-axis means your complete function will multiply by negative. So this will change to negative times 2 power x. The second transformation is 4 units right. Right means x minus something. So it will be changed. X will change to x minus 4 units. So x minus 4. This is the new function gx minus 2 to the power x minus 4. Next is, let the graph of g be translated 2 units up, vertical stretch, and this function. fx is given. We are applying the transformation on this question. See, log base 1 by 3 of x. I can write this. Then first transformation is 2 units up. Up means outside addition. 1 by 3 is in the base. 2 units up means outside added 2. Then followed by vertical stretch. Vertical stretch means the complete function will multiply by outside some number. So here vertical stretch by factor 2. So outside is a multiplier by 2. 1 by 3x plus 2. If you want, you can open it. It will be 2 log base 1 by 3 of x plus 4. This is g of x. So we covered 6.4 up to this. I hope you understand. If you have any doubt, you can ask in the comment section. Thanks for watching.